Hello friends, सबको नमस्ते. So today in this video we will create a model, object detection model using a hardware dataset, and for this we will use a pre-trained SSD BG16 model for it. So that before that, let me show you the dataset. This is a txt file. It's showing that in the dataset we have a three classes, but I have seen that mostly it is used, this dataset mostly used for the helmet, because most of the images is of the helmet only. Okay, so let me show you the images. This is the images. Okay, and these are the labels, so you can say the bounding box details. See this bounding box details. First thing is a class, you can say the class index, and this two you can say is the coordinates, and this two is the height and width. Okay, you can say this is the coordinates of x center and y center of the bounding box. So close it. So let me first open this Jupyter file in Google Colab so that I will explain you everything line by line. I already opened it. Let me, this is your G down. Let me explain you line by line now. This is a G down. You can see the library to connect the Google Drive with your Google Colab. So let me first show you how you can upload your data set, copy link, and just paste it here. Paste it here and just keep this part. You can see this is a unique ID of your data set which you have uploaded in a Google Drive. Just copy this and paste it there. Okay. Now this is your zip file name, and you can download your zip file in a Google Colab. Now unzip that. Okay, let me show you. See, our dataset zip file is come. When we unzip it, you can see this is a dataset with test and train folder and a data YML file. Okay, so these are the libraries which we use for the training and the distribution, creating a dataset. See, we are using SSD classification head, which we change according to our number of classes which we have. Okay, and this is a we can say the weights which we use, SSD 300 VJ16 weights. Okay, so let me explain you this part so that I will not explain you in this. Okay, here I will explain you easily. So let me first print something so that we will get clear idea what is happening here. Okay, see, these are the directories, annotation directories, and the image directory. Let me first create the OS list directory. You already know this variable contain all the annotation file names, and this set the, you can say don't use set here, because I use set for the better pre-processing, but it's not needed. Okay, it's not necessary, you can say. You can say image directory. When passed with the image directory with os.list directory, it to fetch all the file name of the images in this images variable. Basically, images is a list which contain all the file names present in this images directory. Now we will open the annotation, iterate over the annotation file names. First, we will create an annotation file path by just path.join annotation directory and the file name. From this variable, give me the file name. This way we will create the annotation file name. And you can know that in the annotation file name, this thing .txt uh, .txt consider that as txt annotation file, but when we remove that .txt and convert that into a jpg, it's get me the file name of the images file name which present in the images folder. So this way we will fetch the image path. Okay, just open that image by giving the image path os.path image directory and image file name. Now after that we have to get the image size. Why I am getting this, why I am using this line, I will explain you this. Let me open the text at one of the labels. uh, Open this. See this, why I'm using this. See this variables. These so not variable. This values is in a normalized format. I have to unnormalize them. So to unnormalize them, I have to use width and height of the images. Only because only using of that only I can unnormalize them. That's why I'm using this width and height here. Okay. Now I will open that txt file in a reading mode and see this. Let me show you one thing. I want to iterate only one time. Let's run it. I think so. For loop. See this line. Okay, this one break will come here, so that only print one line only. Okay, so let's run it now. See this line, print line. When we iterate over this f, when we print a line here, it will print line first line of the text txt file in this way. It is in this is this time it is in a string format. But to fetch these values one by one, like this, fetch this value, fetch this value, we have to convert that string into a list format, list of the string. So when we use this line dot strip dot split, okay, it's give me the list format of the each value in the present in this line in a string format, complete string. I will get this list of the string. Okay, this way I easily fetch the values. Now so you can see just using the zero in data.0, I can easily get the class index. Okay, now you can see that x center and y center. I already told you that first two values of the line is the x center and y center of the bounding box fetches. Now why I am multiplying it with width and height? Because I already told you these values in an unnormalized format, so I have to convert that in a normalized format. I have to multiply it with width and height. You already know that x coordinate all be x coordinate can be related to the width, so that's why we're multiplying with width. Y is related to height, so multiply with height. Okay, now box width, last two values I already told you, these are the width of the image, width and height of the image. Okay, so unnormalize them. See this class index should always in a int format, so I am writing here int, and all values, these values for better accuracy, x and y etc, it can be in a float value. Okay, now how I am converting them into a you can say bounding box coordinates. This x min and y min, you can say that it is a uh, you can say top left corner, and x max and y center is a top bottom right coordinates of the bounding box. How we can get that? So let me show you this thing. First, hex min means top left x coordinates. How we can get that? Just minus the box width of the x center. You can little bit say this thing is one thing, not a different thing. Okay, this is one thing. In all these three, this is this thing is one thing. Okay, so why, first thing, why I am dividing with two? Because I have to move right side from the from the center of the bounding box till to half of the length of the half of the length of the width. So that's why I have to divide by 2 and just minus it with the x center. Now why let's come with to the one thing you have to know, that for the y coordinates in the image, 0 0 value start at the top left corner of the image. Okay, in mostly in the graph, when we use when we work with the mathematics, the graph in the graph for the y also, y 0 0 start from the bottom. But in the images, when we work with the images, 0 0 coordinates for the y start from the top left. Okay, so make in mind, and according to that only you have to do the calculation for bounding box. So write this time only. to move up from the y center, we I have to first divide the height by 2 and just subtract it. Okay, now x max, just add it, because now this time I have to move right side from the y center, so that's why I have to add it. And my x, just why, because I have to uh, move down to the images, that's why I am here adding it the box height divided by 2. This way we calculate the x-min by bin and x-min by max. Okay, I have get confused that I have said that for the x center I have to move right side, so don't get confused. I mistakenly said that, but let me explain you again that for the x main, for we have to move left side of the x center, so that's why we have to multiply it. Okay, so don't get confused. I mistakenly said that said the right for the x main. Okay, so now this way we calculate the x-min by bin, and what is the use of this line and data I already told you. So no need to run this cell. It's not in, it's not necessary, or you can say not play any role in trading and interesting of the data set. Okay. Now this is a custom dataset class which we use for the data loader to load the dataset and give us the batch. So let me explain you each and every line of this. One more thing I want to tell you that when we use data loader library to load the data, this function name should be same: init, length, get item. This function name should be same according to your data loader only. If you change them according to ourselves, it will data loader will throw the error, or you can say training time. You will get ultimately get the satisfied result. Okay, so get item, length, and this init, this function names will be same according to data loader library which we use. But class name, you can keep any class name. It's not necessary to keep only custom data set. Okay, you can keep any name, but the function name under the class will be same according to your data loader. Now let me explain you. We are passing the image directory, annotation directory, and annotation variable which give me the annotation file name list. Just make the initialize them. Length basically give me the length, how many images we have. Now this, you can say get item basically return the image with the annotation labels. Okay, now let me explain you what is this IDX mean. IDX means you can say I already told you that annotation is a list. Annotation, this variable, this self annotation, this self annotation basically is a list of the annotation. So to fetch the name of the annotation file, okay, we have to iterate over the annotation. Okay, so this index is a, you can see the index value of that particular annotation file name. After getting the file name, we have to first create the image path. How we have to create? Just pass the image directory, and I already told you that let's just replace the .txt from the annotation and replace it with the .jpg. You will get the annotation image file name. So this way we get the image path. Now we have to read that image. Okay, if suppose there is no image, it will throw the error. You already know that when we use OpenCV, when we read that image, the image should be the format which the CV2 read is in a BGR format. So we have to convert that BGR into RGB format. Okay, now this whole thing, this process, till start from here till here, I already explained you everything above in the code. Okay, this three thing language is different, so let me explain you. This annotation file, I will tell you to fetch the annotation file path. Just pass the annotation directory and annotation, because here annotation you already know that it is a file name which we fetch using the IDX. Okay, now this boxes dot labels, because basically boxes will contain the bounding box details and labels will contain the you can say the class ID or class index value. Okay, after getting that, just pass text in the boxes and labels. For line in F, because F, basically F contain all the text, entire text. See this entire text contained in the F. What we have to move line by line, so we have to iterate over it. And just line, I already told you that it contain the line. So ultimately, for loop will be iterate over this, and all the values, all the bounding box values is appended in this boxes and labels. See this int is used here also. I told you that labels should be in a int format, not in a float format. And why I am adding +1 here? Because you know that zero index values, or we can say the class values or class names already start from the 0, 1, 2, 3. So why I am adding +1 at each class index present in the bounding box? See this. Where is that? Where's see? We are using SSD 300 with 16 bits with Coco V1. Okay, for that background index is already fixed for the zero. Okay, zero index already fixed for the zero index. So that's why I have to add +1 at every class index, because you know that we do not have, according to this data set which I have shown you, we have three classes: helmet, person, and I think so head. Three classes. But when we use pre-trained models, one class already added, and it's is a background class at the zero index. Okay, and it's fixed. You do not change that. It's, I think so there is a way to change that, but mostly if for the ease of, you can say, for the easy processing, we do not change that. Just change this class index +1. Just after that, just up it changed to into tensor format, because PyTorch already working in the tensor format. So that's why this float 34 int 64. Okay, just give that, you will get. Now, if suppose any data augmentation or or a pre-processing is there on a image, just add that to the image, and just make a dictionary of the target boxes and labels, and pass this image target. This way, our custom dataset, you can say custom dataset class created. Now, this is the main thing. I will explain you each and everything here so that you will not get confused. No, no need to print it here. Okay, we have to print in channel and print num anchors. Okay, before that print model also, so that I will explain you each line of it, and you will not get confused why I have used that line or why I have not used that line. So now let me run it. Starting the weights. Okay, it's completed. Now just copy this entire thing and paste it in a text editor, so that I will explain you easily. There is no need of this. Now see this. Uh, First see the architecture of the say this is your SSD BGA 1600 model architecture. You can see that this is a backbone, this is a layers, extra layers on all these layers are conventional layers. So see, each layer, each sequential layer, not particular one layer, each sequential last layer, each sequential last layer, sequential, you can see the way we combine all the layers is a sequential way. Okay, each sequential connected to this last, you can say, the head of the SSD model. Okay, mind line clearly. Each sequential last layer is connected to the head of the SSD model. You can see this in the architecture. Each last layer is connected to the head of the head of the SSD model. Now, one more thing, when you create the model from the scratch when we create it, you already know we have to pass the in channel and the out channel. For the in channel, if you suppose when I talk about the second layer of the for the python CNN model, when we are getting the model itself from the scratch, for the second convolutional layer, you will want the in channel value, and that in channel value come from the first convolutional layer. Okay, from the first convolutional layer only you will get the in channel value, and that particular in channel value is the out channel of the first convolutional layer. Okay, so that's why you have to that's where you can connect the convolution layer of first and second this way. Okay, uh, let me add one line again, that out channel of the first convolutional layer is act as a in channel of the second convolutional layer when we create the model from the scratch. Okay, now let me show you. Where is the code? See this. When we when we want to update the classification head, we want in channel from each conventional layer, because each conventional layer of the sequential last layer is connected to the head. So we want out channel, so sorry, not in channel, out channel of these layers, so that I can easily connect them. Okay, so get that to get that, we will use this utils retrieve out channel. Retrieve out channel. See this. Retrieve out channel is a function which retrieve me the out channel of each sequential last layer, which act as a in channel. Which act as an in channel to connect to them to the classification head of the SSD model. Just pass the model backbone and size the which image size you are throwing during training time. Okay, so see this. Don't see this number classes here too, but it's just you can say the default value. We will change that. Now, what is the use of number of anchors here? Okay, say this. Uh, See this. This is an image, and you can see that particular this divided into a grids, and each grid, how many anchors, how many bounding boxes there at each grid cell. One, two, three, four. One, two, three, four. Three anchor boxes. These bounding boxes at each cell is known as anchor boxes. Now this for this part, see this. One, two, three, four. Four anchor boxes. 4 by 4 into feature map. Okay, this is known as anchor boxes, which you can say act as a object detection of large and small boxes in an image, by the image is divided into a grid cell. Okay, this is known as anchor boxes. So this thing is also required in a SSD model, in this SSD model, because SSD model work also use anchor boxes for the object detection. So to how to retrieve that, how many anchor boxes at per sequential last layer, how we have to retrieve that. For that, we have to use this function, model anchor generator num anchor box num anchor location. Now let me print I already printed. So see this. So this is the first sequential, and this is the last layer of it. Okay, this is a second sequential, sequential, and this is the last layer of that. This is a third last layer. This is fourth last layer. This is fifth last layer. Okay, now you can see this anchor generator. See this. Let me show one thing. Anchor generator, model dot anchor generator means in model go to anchor generator and num anchor per location. But num anchor per location is just a function, is not any any very part of this. Okay, when we move to the anchor boxes and use the function num anchor per location, we will get how many number of anchor boxes at part like anchor layer. Okay, we will get that. Now this is one part. Now second part start from this here SSD and regression head and classification head. We have to convert that classification head. How we will convert that? Say this. This is the last layer. What is the out channel of this last layer? 512. It's now here it's act as an in channel. This way we connect them. Now let me show you this here. What is the, you can say, what is the out channel of this? Out channel of this is 1024. It's act as an in channel of the of the second layer of the classification head. Say this 1024 here. Now this layer out channel of this is 512. It's act as an in channel 512. 256, 256, and this 256 here and again 256 here. Okay, now see here 3 4 here means here two into sequential matlab means two sequential is here of two of same architecture. So that's why here 2, that's why here is multiplied by 2. Okay, it's like this. Now according to this, how many layers, how many classification head is you can say classification head layers contain? 1 2 3 4 5, means total 5 layers is here for at the classification head. According to this, if suppose 5 layers is here, the 5 means we want list of 5 anchor boxes, means how many number of anchor boxes at particular layers presented, means 5 values should be there. Say this 1 2 3 4 5 6, means 6 layer is there, not 5, 6 layer is there. Now here see 6 values of anchor boxes. Now already know that 512 1024 1512 from where it's capped, it's the out channel of each sequential last layer. Okay, now let me show you how this value is calculated. 364 546 546 546 and 364, how it's calculated, means out channel of how it's calculated. Let me show you. Say this 88 89 90 91. In Coco dataset 91 classes is there. Okay, now see for the first first conventional layer, when we multiply 91 with 4, means 4 bounding box at each grid cell is there, not 4 bounding box, 4 anchor boxes at each grid cell. So when we multiply by 91 into 4, you will get 364. Same for this second layer, when you multiply 91 with 6, you will get 546, and same 44. But this way it's calculated the out channel value. Okay, according to the number of classes which is have in Coco data type, it's contain 91 classes, so it's multiply it with 31 here. Now regression hat, how this 512 102 512, I already know how it's calculated. Now how this 16 is calculated, 24 is calculated. You already know that regression head at the output it's give us 4 values, x center, y center, width and height, or you can say x min, y min, x max, y max values, means 4 values. Now 4 anchor boxes is there. When you multiply this 4 into 4, you will get 16. 16 into 4, 64. 4, you can say that 4 is a bounding box values, and 6 you can say that anchor box, number of anchor boxes. This way these values are calculated. Okay, so I already explained you each and everything. This transform, general rational transform, you already know this is the mean values, standard deviation, all this size and size. So let me come back in a model. Okay, so I have already explained you what is anchor boxes, what is in channel, why are we are calculating it. After all these calculations, just pass the in channel, number of anchors and number of classes. And number of classes which we have is 4. Why 4? Because we have a helmet, head, person, and one class is already added is background. Okay, that's why 4 classes, and the size which we want is 640. Here my transform mean dot size is size This is the size which we will use for the image. So let me run it. It's already done. Now this is a model after all the pre-processing or change of classification had according to our number of classes which we have. See here 16, 24, 24, 24. We cause 16 here because we have four classes only. We do not have 91 classes. We have four classes, and first anchor box contain four bounding box, four anchor boxes. So 4 4 is 16. This way values is calculated. Now just give the train actor annotation directory, get the test annotation annotation which contain the annotation file names, and first create the train dataset class, or you can say the object using a custom dataset. Pass this all variables because we have to initialize them. Image directory, annotation directories, annotations, transform, just convert the image into a tensor. Okay, now this is a data loader library which we use because just pass the train data set. Batch size be what is for. Shuffling is you already know that is shuffle the all the images. Okay, now what is the meaning of quotation lambda x tuple dot? Why we have to use this? See this. It's what is the use of this? Let me first run it. Okay, say this lambda x tuple dot how to combine a list of sample into a batch. This function basically used for this. Now let's break out. Here x you can say we are using four, means it's contain four sample in a list format. Okay. Now each sample, you say each sample is a tuple. Sample one is a tuple of containing two things: image tensor and labels. Okay, now when we use the zips of x and you can say this function, basically it contain it mean we it basically we passing the thing like this: image label, image label. You can say that because sample one is a tuple, sample two is a tuple, sample three is a tuple, sample four is tuples. After zip, basically it contain, basically you can say it's give me the so you can say and b cross it. This give me the tuple. This give me the tuple of the tuple. Tuple is this tuple is basically referencing the entire tuple, and each tuple here image one and the labels. This way it's we use this zip here which give me how the list of the sample into a batch is combined. Okay, now first give me how many batches we have. We have 250 batches. Now this device, you already know that why we are using device, because we want that entire model images and the label should all be always be on a same device. So that's why we have to use this function if torch.co.available give me that is either GPU is available or CPU. It's give me the device name. Okay, now model for p in model the parameter p is required. See this, when we model the parameters, when we iterate over each parameter, or we can say weight of the model, it's contain one attribute. It says required grade. What this required grade give me the detail that particular weight is updatable or changeable during training or not. If it is updatable in during training, so make a list, make a list of that. Otherwise we do not require that weight. Because in optimizer we only pass those weights or parameter that is updatable during training. Otherwise we do not pass that. We are using SDT optimizer, just pass the parameters. Learning rate is this, more phantom is 0.9. Now we have to use a scheduler. Why we have to use a scheduler? Scheduler is just to avoid the overfitting. Okay, and sometimes it's also increase the accuracy. Just pass the learning rate optimizer, because optimizer play crucial role in updation, so we have to pass that. Stab dot size is 3, means after every third epoch it's changed the learning rate value. Gamma basically give me the thing that learning rate value should multiply with 0.1. So let me give you one you can say example of it, mathematical example. Suppose this one is epoch 1, epoch 2, epoch 2. Learning rate value remain the same, and if suppose and after third epoch it's multiplied by 0.1. The learning rate value changed after means now this is act as a first epoch, second epoch, third epoch. Now it's again multiplied by 0.1. This way the learning rate value scheduler acts. Now we have to plot the images. See this, we have four classes. According to our dataset, that data.yml file, we have only three classes: head, helmet, and person. But when we use pre-trained model Coco dataset, its background is already included and act as and it is placed on a zero index. So this is a figure which represents an entire figure. X is for the iteration on the subplots. This is plot to subplots. 1, 2 means we are plotting only two images because one row, two column. Okay, figure size is 10 by 16. X dot here, X is in a 2D format, and now when we use label, it's in a 1D format for the ease of iteration over the subplots. Let's first we have to make a iterator over the train data loader. Next will give me the two things: images and target. Images basically contain the four. We are using batch size 4, so it contains 4 images, and targets basically give me the bounding box and the label values of 4 images. Now CMY basically it's you can say the shortcuts of the colors value which we can use during a plotation in a IAM show, because in a plotation. Okay, now why we have to use permute here? Because when we use transform to tensor, okay, so it convert the dimension, or you can say the shape of the image from HWC from CHW. But use when we have to use I'm show. It's required the image, okay, in a HWC format. So to convert that, we have to use permute 1 to 0, that which convert the CHW into HWC. Now we have to use this target.idx to get the image details according to the index. Now we have to convert them into numpy boxes and labels for the ease of iteration. Okay, now we have to see, you can say that for one image might be there is more than one bounding box, so we have to iterate over it. And same for the labels. Okay, zip format, it will give me the box and labels values uh, at each iteration of same box. So one more thing, that why we have to plot the images before training, because it's get one idea that the train data loader or the data loaders which we have used is correctly assigning the correct bounding box on a correct image. Okay, sometimes there is a chances that when we use a data loader for getting a data set for getting a data set before training, it might be chances that your bounding box is not representing the correct images. Okay, so that's why we have to check that before training. It's give us the idea. Now, how we can get the width and height? Just multiply this x min by min, x min by max and by min. After getting this in patches dot rectangle, pass the x min by min, width, height, line width, color, face color. Now this add as patch text. Add patches means it add the rectangle. Add text now. According to text, this will be the label. See this helmet and helmet. Let me now run it. Here I'm sure we have to show the images. Okay, it's working. Me is not working. It's you can say that the correct bounding box is representing the correct image. Means our mapping is correct with same mapping is correct between the images and the targets. Now come to training part. Let me iterate over the epochs. See here I am using number of epochs is only 5, or instead of 5 I will use 2 here, because I already trained this model and download the weight file when we had to use the epoch value 50. Okay, so for completing the video at less time, I have to use 2 here. Okay, so don't get confused. You can use either 50 or 50 to 100 between for better accuracy. But this time I'm just using 2 here because I already trained this model on 50 POC and download that weight file. Okay, now let me explain you. This is a message which we print during training. Now model trained model is in a trained model means weights should be updated during training time. This train learning loss give me the loss value at each batch, and after using this, when iteration of each batch iteration over each batch is completed, we'll get train loss value using this. Initially, its loss value will be 0. Now, just you can say print the masses. Now we have to iterate over the train data loader. This basically is two lines: data targets and images. I already told you that models, images, targets, all thing has to be on a same device. So that's why we have to use this. Now pass the images in target. Now sum of all the losses. How many losses lost? It basically give me the loss value, and we have to sum that so that we can get the one value of all the losses. Now optimizer dot zero grade, converting gradient value to 0 for per batch. Why we have to use this? At each iteration of the if suppose we do not use that, and we do not convert the we can change the gradient value to 0 before updation of the weights, because if because in a next batch, when we do not use the gradient value, it will accumulate the gradient value of the previous batch with the current batch and update the weights value. But that particular updation of the weights is not successful, or you can say not good, not good for, or we can say not correct. So that's why we have to use zero grade, which convert the gradient value to 0 before updation of the weights, so that the gradient value will not get accumulated to the current batch for of the current batch for of the previous batch gradient value during iteration, or we can say during training. Loss.backward. This losses.backward. Here losses.backward will calculate the weights value according to the losses. Here it's not, and here the updation of the weights does not performed. Optimizer.step basically updates the weights value. Now we have to training loss value. We have to add loss value of each batch. Now scheduler dot steps. Basically, I already told you that scheduler step will change that learning rate value at every third epoch. Now print the value. Now here train data set. We have train data set. Here train learning loss, when this whole you can say whole for loop will completed, you can say the trained learning loss after completion of the for loop, it contains the loss of all the images present in the entire data set during training time. So that's why we have to divide it with the trained data set, not with the length of the trained data loaders, with the trained data set, because this trained learning loss after completion of the loss represent the loss of entire image present in a trained directory. Okay, so that's why we have to multiply it. Let me show you one thing so that you will get better idea of the losses used here and how it's working here. Say this. It's means lost dot dict. First thing, lost dot dict. When we pass only images in target, it's giving me two type of loss: classification loss and regression loss. I already told you when I'm explaining the model, how I'm creating the model according to number of classes. It's contain only two head: classification and regression head. So that's it's only give me the losses according to that only: classification loss and regression loss, or you can say the bounding box regression loss. Its value is 2.915 12.18. When you add this 12 with 1, 2, you will get 14. So that's why it's giving me sum of these two losses. So this way the calculation performed. Okay. Now I have to run it for the iteration for the training part. After that, I will save this. You can say this is a one method to save the model. And you if you used if you will use this way to save the model, you have to load the model in this way. Okay. Now this is a testing time. Sorry, here SSD will come. Okay. Save the model. Testing time. So let me explain you. You can already explain this line, what is the use of this line model, and everything should be in the same device. Now using the function create model, which give me the model according to a number of classes which we have. Okay. And we have to load the model. ssd custom.pht is a weight file name. Okay. This is a way when you save the model in this way. If you save the model in this way, you have to load the model in this way. Now model.evaluation give me things that in this time we are evaluating the model, we are not updating the weights values. This to value I already explained you things that before training we have not performed any pre-processing on the image, just convert that image to tensor. So one thing we have to perform only. Now this is a test directory which contain the images, list of all the test file names. These are the class name samples. First, open the image by just pass a test directory and random choice test list files. It's randomly choose the file name, and according to that only we have to get the image path, open that image path, perform the transformation on that image, and unsqueeze it. Why we have to unsqueeze it? Because during training time, we pass the image in the batch format, or you can say when we can say that. Uh, during training, the size, or you can say the dimension of the images is bchw, where bh batch, channel height and width. Okay, so the same format, same shape, we have to pass the images during testing. So when we unsqueeze, sorry, when we unsqueeze it, it add one dimension to the image, and that dimension is batch, and is here the image convert to bchw, but b value will be 1 because only one image is present here. Okay. Now with the torch no gradient, I told you that no gradient is used, no operation is there, just pass the image tensor. Now to fetch the first image prediction, or we can say one image prediction, we have to use the 0 index value. Okay, to get the prediction of the first image. Now permute numpy, just change the chw into hwc, because image tensor is a different thing, and image here is converted into a tensor. In here image is converted into a chw format using a transform, you can say transformations. Okay, now we have to convert it into 1 to 0 to represent that image into a I'm sure, because image format which is required to I'm sure is hwc. Now prediction basically output of the model, but it contains contains all things in a dictionary format. So bounding box, give me the bounding box coordinates, labels, scores, give me the values of each thing. Okay, now we have to iterate over it to fetch each thing one by one according to that. So if a score 0 1, because score contains many things, scores value is, you can say, vary from 0.0 to 0 to 1. Okay, so we want high percentage score value bounding box. So 0.8 means here 80%. If suppose the score is greater than 80%, equal to 80%, we only draw that bounding box only, because we get 100% surety that particular bounding box is correct. It's not representing other object. Now this whole thing I already explained you everything. Okay, now run this. Let me see, it's completed. Oh, I have not stopped this sprinting every time. Let me pause this. Okay. Now I will upload the weight file which is trained on 50 epoch and test that. Okay. So let me pause this. So friends, this is a weight file. This is weight file which is trained on 50 epoch. I already changed the model name here. So let me run it and see the result of the model which is trained on 50 epochs. Wait for a while here. It's, I think, stay take the time because we are not using GPU in Google Colab. We are using CPU here. Okay, so let's wait for that. See the result. Helmet, and it's pretty good working well, but mostly it's working on a helmet because I already told you most of the images present in the dataset is of the helmet only. So video is over, explanation is over. So please like, share, and subscribe because it's motivate me to give you more videos like this, like where I will explain you deeply at each line. You using of use of that line, why we are not using that, each and everything I will explain you. So coming videos will be on a image segmentation and some other projects. It might be on some other projects. So please like, share, and subscribe because I will give you each and everything of each detail of the line. Okay, please like, share, and subscribe, please.